Look at another person's face for even half a second, and you already know something about them. Annoyed, delighted, nervous, bored. That instant read happens so automatically that we barely notice how strange it actually is. A handful of tiny muscle twitches, and an entire internal state gets broadcast to anyone paying attention. Here is a stranger question, though. Does the shape of a society decide how complex its faces need to be? What if the most laid-back groups, the ones without a strict pecking order, actually need a richer facial vocabulary than the strict ones, just to get through an ordinary day? Charles Darwin was already circling this idea back in 1872, in a book most people have never even heard of, called The Expression of the Emotions in Man and Animals. His argument was that facial expressions were not some uniquely human invention. They were inherited, shaped by evolution, the same way a wing or a claw is. It took more than a century for that idea to get a rigorous toolkit. In the 1970s, a psychologist named Paul Ekman built something called the Facial Action Coding System, FACS for short. Instead of vague labels like happy or sad, FACS breaks a face down into dozens of individual, objectively identifiable muscle movements, called action units. Ekman had already shown something else that still gets cited constantly. He traveled to an isolated tribe in Papua New Guinea that had never seen a film or a magazine, showed people photos of faces, and they matched the same core emotions that a stranger in California would. What makes FACS genuinely powerful is that it does not stop at humans. Researchers have since built matching versions for chimpanzees, for horses, even for dogs. The dog version turned up something almost eerie. Somewhere during thousands of years of domestication, dogs seem to have evolved a muscle around the inner eyebrow that wolves barely have. It is the muscle behind those exaggerated puppy dog eyes that are so hard to resist, and it looks a lot like a face that evolved specifically to be read by us. Horses got their own version too, and it turned up something nobody expected. A horse's face has around 17 distinct action units on its own, more than researchers originally mapped in a dog, all wrapped around a set of huge, deeply mobile ears that add a whole extra channel of signaling. So if a face can evolve to fit its audience, here is the next question worth sitting with. Could an entire species' face evolve to fit the audience of its own society? That idea already has a name in behavioral biology. It is called the social complexity hypothesis, and the basic claim is almost common sense once you hear it out loud. Animals living in complicated social worlds, where alliances shift and today's friend can be tomorrow's rival, need a richer communication system to keep up with all of that. Animals living under simpler, more rigid social rules can get by with a smaller, blunter toolkit instead. You can see a version of this trade-off across the animal kingdom once you start looking for it. Wolves are a great example, mostly because of a myth about them that will not die. For decades, popular science talked about an alpha wolf clawing its way to the top of an unrelated pack. Real wild wolf packs are not that. They are family units, a breeding pair and their offspring, running on cooperation more than raw dominance. Compare that to naked mole rats, which run something closer to an actual dictatorship. One breeding queen suppresses reproduction in every other member of the colony through sheer behavioral policing. Even among our closest relatives, the difference is stark. Common chimpanzees run on a tense, male-dominated hierarchy with real violence at stake. Bonobos, a separate species just as closely related to us, resolve most of the same tensions through affiliative contact instead. Elephants sit somewhere else on that map entirely. Their herds are led by an older matriarch who carries decades of accumulated social memory, and relationships stretch across multiple generations of daughters, granddaughters, and extended family who are not competing for one single throne. Few animal groups make that same contrast easier to study up close than macaques, a genus of more than 20 monkey species spread from Japan all the way to North Africa and the rainforests of Southeast Asia. A primatologist named Bernard Thierry spent decades cataloging macaque social lives and landed on a simple sliding scale, grading their societies from the least tolerant all the way to the most tolerant. At the strict end of that scale sits the rhesus macaque, the same animal you might recognize from decades of biomedical research. Rhesus society runs on a steep linear hierarchy. Conflicts escalate fast, subordinates rarely fight back, and a very specific, stereotyped baring of the teeth gets used constantly just to keep the peace. Step out of line in a rhesus troop, and the consequences tend to arrive quickly. That particular submission signal, a silent baring of the teeth, shows up across a huge range of primate species, and some researchers think it is the evolutionary ancestor of something we do every single day without thinking about it. A human smile. At the tolerant end of the scale sits the crested macaque, native to the island of Sulawesi in Indonesia. Rank still exists there, but it barely resembles a monarchy. Fights are shorter, reconciliation afterward is common, and lower-ranking animals routinely get away with things that would be unthinkable in a rhesus troop. Sitting right in between those two is the Barbary macaque of North Africa, tolerant enough to allow some negotiation, but nowhere near as relaxed as the crested macaque. If that species sounds oddly familiar, there is a good reason. A population of Barbary macaques has lived semi-wild on the Rock of Gibraltar for centuries, posing for tourist photos and occasionally raiding an unattended sandwich, Europe's only wild monkey population. None of this is just a hunch about which species happen to seem friendlier on camera. Researchers already had a hint that tolerant macaques might be working with a genuinely richer signal set, and it came from an unexpected place. Their voices. Earlier work comparing macaque vocal calls found that tolerant species used calls that were harder to tie to any one specific situation, a blurrier, more flexible vocal vocabulary. Stricter species, meanwhile, used calls that mapped almost one-to-one onto a single, predictable meaning. A similar pattern shows up completely outside of macaques too. Among chimpanzees, pairs with a stronger social bond use a noticeably larger repertoire of gestures with each other than pairs that are not particularly close. The likely reason is simple. A deep relationship just generates more different kinds of situations that actually need to be communicated about. Put all of that together, and a clear, testable prediction falls right into place. If a tolerant, less predictable society really does demand a richer communication system, a monkey's own face, the fastest and cheapest signal it carries into every interaction, should show that exact same pattern. Think about that for a second the next time you catch yourself half smiling at a stranger to diffuse an awkward moment. You might be running a script that is millions of years older than language itself. So did the data actually back up that prediction? A team of researchers set out to actually test it on the one part of the body every single primate brings into every single social interaction: the face. They picked 3 macaque species sitting at 3 different points on Thierry's tolerance scale: the strict rhesus macaque, the tolerant crested macaque, and the in-between Barbary macaque. Then they spent months filming all 3 going about completely ordinary life. Greeting each other, fighting, backing down, making up. In total, the team coded more than 3,000 separate social interactions across 389 animals, using the primate version of that same coding system Paul Ekman built for humans decades earlier. They tracked every individual visible twitch of facial muscle, rather than lumping whole expressions into broad categories like a bared teeth display or a lip smack. The pattern that came back matched the prediction closely. Crested macaques, the most tolerant of the 3 species, used the single widest range of facial movements across every type of interaction the researchers measured. Friendly, aggressive, and submissive alike. In numbers, crested macaques scored an entropy ratio of 0, 52 in friendly interactions and 0, 67 in submissive ones, both well above rhesus macaques, who scored just 0, 38 in those same two situations. Rhesus macaques leaned hard in the opposite direction, relying on a small set of highly specific, almost ritualized expressions. The same signal, deployed over and over, tied tightly to the same narrow meaning. On average, rhesus signals landed above 0, 7 specificity across all three situations, and hit 0, 93 in submissive contexts alone, while crested and Barbary macaques reused the same facial movements far more loosely, often scoring below 0, 5. The researchers pushed the comparison one step further, training a computer model to guess what kind of interaction was happening using nothing but the pattern of facial muscles involved. For rhesus macaques, that model nailed the guess almost every single time with a kappa score of 0, 92, dramatically better than chance. For crested macaques, the least predictable of the three species, accuracy dropped to a kappa of just 0, 49, which is exactly what you would expect if their facial behavior really does carry more built-in nuance and ambiguity. The researchers are upfront that this is a correlation across species, not proof that one thing directly caused the other. And body size differences between the three species were far too small to explain the pattern on their own. But the result lines up neatly with what those earlier vocal studies had already hinted at. And the authors point out one more detail worth sitting with on your way out. Humans arguably live inside some of the most tangled, constantly shifting social networks of any primate on the planet. We also happen to have the single most mobile, most expressive face of any species alive. This study, higher social tolerance is associated with more complex facial behavior in macaques, was led by Alan V. Rincon and colleagues, and published in eLife in 2023.